Hi everybody. So the other day we left off on zero and negative exponents notes. This is the sheet that we worked on our notes on Friday. We had finished through example 5. This is example 6 I'm starting with. So why don't you pause the video for a minute and see if you can work example 6 exactly like we talked about the other day, where we talked about reciprocal for negative exponents and simplifying down to an expression that no longer contains any negative exponents. Okay, hopefully you've got a chance to try example 6. So the only part of this with a negative exponent is p to the negative second. And so we're going to take the reciprocal of that, which means essentially we're just moving it up to the numerator and it becomes a positive exponent. So my final answer will just have m squared staying there, p squared in the numerator now, and in the denominator I have the original n to the first power. Anything with a positive exponent stays where it is. Okay, now in example 7, you see that there's now a number to a power. Never leave a number to a power. This is going to have to be simplified down to, like, for example, like if it was 5 squared, you'd have to express it as 25, not as 5 to a power. Okay, so let me change that to simplify. If you want to give that a shot, pause the video, and then I'll go through the solution. Okay, so right now everything is in the numerator over 1. 3 to the negative second is going to go down to the denominator as 3 to the second, but really that's just 9. So I'm going to write the number 9. Okay, and again, remember it's really 1/9, right? 3 to the negative second is really 1/9, but since we're incorporating all this into one fraction, I'm just putting a 9 in the denominator. And then you'll notice m to the fourth has a positive exponent, so that stays in the numerator. So that's the reason why I don't have to write the 1 over the 9, because it's 1 times m to the fourth, which is just going to appear as m to the fourth. And n to the negative fifth has a negative exponent, so that's going into the denominator. Again, really that's really 1 over n to the fifth, but we don't see the 1 because it's multiplying by everything that's already there. So this is my final answer, simplified with no more negative exponents, and also now no more like number to a power. 3 to the second gets simplified. Okay, we go to example 8. The examples are just getting a little bit more complex. So the way I approach these, I always take one part at a time. So like I'll set up my fraction and I'll start with the 5. 5 has a positive exponent. It's 5 to the first, so it stays. M to the negative third has a negative exponent. I'm going to take its reciprocal. It's going down as m to the third. P is to the first power. There's an invisible first power there, so P stays. Remember from the other day, r to the 0 is 1, but I will not see the 1 because 1 times what's already there is just what's already there, so I don't have to show that. And then I move on to the denominator. 2 to the negative third, right, is going to go up. It's the reciprocal. 2 times 2 times 2 is 8. 8 is going to go to the numerator and multiply by the 5. Be sure not to stick the 8 in the middle there between the variables, because it's going with the coefficients. It's going to multiply on the left side with any other coefficients that are there. X squared has a positive exponent, so it stays in the denominator. Y to the negative fifth, I'm going to take its reciprocal. It's going to go up as y to the positive fifth. And z is to the first, so it's a positive exponent. It stays. I'm now going to clean this up a little bit. I'm going to multiply. I'm going to organize things alphabetically if they're not in alphabetical order. 8 times 5 is 40. P y to the fifth over m cubed x squared z. And there's your final answer. Okay, so your final answer again should not contain any negative exponents. It should not contain a number to a power. It should also not contain any 0 exponents. Those get simplified to 1. Okay, you should pause the video and you should try example 9. Okay, I'm going over example 9 now. 8 to the negative second is it's really 1 over 64, so I'm putting the 64 down here. X stays, it has a positive exponent. Y to the negative third goes down as y to the third. Z squared stays, it has a positive exponent. Now, in the denominator, -3 is not a negative exponent. It's a negative number. So that stays where it is. It's going to multiply by the 64. So I'm just going to write it as like -3 times the 64. These two are going to get multiplied. A squared is going to stay. B to the -4th, I'm going to take its reciprocal. It's going to go up as b to the 4th. All right, now I'm going to clean this up. So I have, I'm going alphabetical. B to the 4th x z squared in the numerator. 3 times 64 is going to be 192. It's negative. Now this negative, remember, a fraction with one negative, it doesn't matter where you put the negative. So it's kind of a little bit nicer to just slide it up. So I'm going to move it up here. It doesn't matter where you put it. And then a squared y cubed. And there's my final answer. If on an exam, if you have your variables that are not in alphabetical order, that's okay. I'm not taking off any points, but it's just a little bit nicer to show it in alphabetical order. All right, so that is, this finishes Friday's notes, and this allows you to finish the sheet that was assigned on Friday from homework. Okay, you're gonna go on to the next set of notes. We're gonna do a little bit on that, and then you'll be able to do the second part of the assignment.